Hey everyone, and welcome to this practice on processes in operating systems. On this lesson, we are going to solve the question 1. This question says, create a C program with the name of processes1.c that sequentially creates as many processes as there are arguments -1. This is because the name of the program also doesn't count. If executed with no arguments, it should display an error message and also exit this program. Now, each child process screens the name of the argument and exits. The parent process waits for its child to finish, writes the child's PID, the process identifier of the child, to the screen, and also exits. So, very important here, this notion of sequentially, okay? This is something we already studied previously in this course, okay? We need here to create sequentially the children. Very well, so let's start solving this first question. First of all, let's create a new C programming language file. The name of this file that we have named it is practice.c. You can here choose any name, okay? And let's begin by including the libraries that we need. First of all, the standard input and output header file. To be able to work with input and output, we also include the unistd header file that provides access to the POSIX operating system API. Since we are going to write messages, we are also going to be working with strings, so we include the string header file. We also include the standard library of C. And now finally, since we will need to here create the children sequentially, we will work with the wait PID system call. So since we are going to use this wait PID system call, we need to include the system types of the wait function. So now let's begin defining our main program. Since in this program we will need here to work with the arguments that we pass, right? We are going to also here use the two arguments in C, which is first the arguments counter. Okay, this is an integer number providing how many arguments we have. Keep in mind that always the first argument is the name of the program itself. And then we have here the array of pointers to access all of the arguments that we pass in this program. Now, very important, on this question, we need to create as many children as there are arguments -1. So essentially, if we don't provide any arguments, we only execute the program, we need to here notify the user that he needs to supply the arguments, otherwise we are not going to create any children at all, right? So here we need to have a conditional statement. If the number of arguments, the arg counter, is greater or equal to 2, it means that the user, okay, has provided at least one argument, right? The user may here have executed the program or the practice, in the case of the executable file to be named this, and for instance the argument high. Okay, this configuration gives us an arg counter equal to 2, because always the executable also counts. So here we have 1, okay? So if we have something like this, how many children we need to create? Well, we need to create the number of arguments -1, since the name of the program does not count. So in this case, we will create 1 child, right? For instance, if the user provides 2 arguments, for instance, high and 55, now the arg counter is 3, we will create the arg counter -1, so we will create here now 2 children. So very important to specify this if condition. So if the user provides arguments, at least 1, we are going to do here a for loop, okay, and we are going to create as many arguments, or basically as many children, as the number of arguments -1, right? So here, it is important to collect, if we want to collect all of the arguments, okay, this index position of the arguments, if the argv 0 is always the name of the executable, the argv1 is the first argument that the user provides. So we want to start here checking for the first argument. While we keep here reading and we don't arrive to the counter of the arguments, we keep here incrementing this iterative variable I. So now let's create the children. Remember that we can create children with the fork system call. With this we create a child, and this system call, the fork, returns 0 if we are the children, and if we are the parent, the fork returns the PID of the child that has been just created. So here let's define a variable PID, okay, and here let's set the PID to be equal to the fork. So now here, providing a returning value, we can now here check if we are the child or if we are the parent. So let's start if we are the child. So here, if the PID, if the process identifier, the returning value of this fork is 0, okay, it means that we are the children. So here we have the child code. And if we remember from the question statement, each child process screen shall display the name of the argument and exits the program also. Okay, so here, let's print on the screen with a printf the argument. And we can provide the index of this argument, so we can have the argument 1 is this one, the argument 2 is this other value, this argument 3 is this other. So we can here provide, for instance, a decimal value, which is going to be the index I, okay, is, and here we pass the argument, which is a string. Finally, we add a line break and end of line. We can do this with a \n, okay, and here we can provide, first of all, this substitution. This is the index I. And this second argument here is the position, okay, essentially, and we want to access the value of this position. So we also need to use this variable. However, we want to have the value of the argument. So we can just type here argv I, so that this argument string is the value at this given position, right? It is the argument, okay, argv at this position I. Okay, now we can close this print, we can add a semicolon. So essentially what is going to happen is this is going to print the argument. The position is the value of the argument. So if the user writes something like this, program or practice high 92, okay, then this child is going to first print, or let's just say high, okay, first, the child is going to print the argument 1 is high, okay, and then the other child is going to print the argument 2 is 92. So here this t is the position of the argument, okay, and this is the value of the argument. Again, this is only done by the children, okay, the parent will not do this. Now finally, we need to leave this program, we need to terminate this child. Remember that we can terminate a process with the exit system call, and here we can provide the status of this exit, okay. Normally, if you just want to terminate the program with no errors, you provide the status 0. So now we close the child code, and with this we are done with all of the work of the child. Now remember that this fork, okay, can also return -1 if there are any errors, okay, when here providing this fork system call. So when this returns -1, it means that the child has not created, okay, has not been created because there was an error. So we need to notify the user for this. And also we need to finish the program. When this fails, we need to finish the program. So here also, we need to consider the case if the returning value of this fork is less than 0, then we are going to print an error message and we are going to exit this program, okay. And we are going to do this with a new auxiliary function, a very simple one. So let's just name this function error and exit, where the first argument we provide the error. So here let's just type error in the fork. And as a second argument we provide the exit status. So here let's just use 1 for the errors. Okay, so if 0 is for living normally, 1 is for living for the errors. Now we can close this brace. And now let's define very quickly this auxiliary function in here. So let's copy, let's go here above. This is going to be a procedure with the name of error and exit. The first argument of this procedure is going to be here a string, so it's going to be an array of characters. And then the second is going to be the status for living, right? So here let's just say int error status, okay. So here what we do, well, first of all we need to print the message, okay, that there has been an error. And in C, when you normally want to print something, but it is because something failed, okay, you don't normally use the printf. Instead, you use the function p_error. This function prints an error message to the standard error in C. And this function only receives one unique argument. This is the string we want to write. So this string is this s, okay, the one that we pass in here. So we write this, and the exit status is 1, so it is this error status, like this, okay. So this is our function to error and exit, okay. And also this error status is going to be on the exit function. So we print and then we exit with this error status, like this, okay. This is our error and exit function, so that we print an error, okay, the error message on the first argument, and then we leave the program. We need to terminate the program with this error status that we provide on the second argument, like this. Keep in mind that we're also using here the exit system call, but now this exit receives another status than the normal exit. So this is not a normal exit because we have another exit status. Okay, so now we can continue. We have already defined what the children need to do. We also defined the error case. Now we only need to define the case for the parent, right? So here let's define the parent code. This code is only going to be executed by the parent because otherwise the PID will be 0, we will be the children, okay? Or the PID will be -1 and we will have an error. So if we arrive here on this line, it means that we are the parent. So here on this question statement, this specifies that the parent process waits for its children to finish, writes the child's PID to the screen and exit, and this is sequentially. So the parent, okay, process waits for one child to finish. Once this child has finished, then we can create a new child, okay? So we will have here sequential scheme. Remember, we already studied the sequential scheme previously, okay? The idea is that only one child is executed at each time, and we only create another child only when the last one created has terminated. So we are here the parent, okay? The parent creates the child 1. The child 1 will do all of its work, it will finish, and then once it has finished, we'll create a child 2, then the child 3, and so on, okay? So only one child is going to be executed at each time. This is what a sequential scheme is. So here, if we are the parent inside this for loop, okay, we need to wait for the child to finish. So here we just type wait PID. With this, we are going to wait for this child to finish. Remember that the first argument can be -1 or the PID of the child. Since we know what is the child PID, okay, we know that because this value here, this system call and this function fork returns the PID of the child if we are the parent. So here, if we just type PID, this parent will wait, okay, precisely for this child to finish. Since we only have one, there's not going to be any problem. But we prefer here to use -1 because with -1, the parent process will wait for any child to finish. This is more general, okay? And also what you're going to use when you have a concurrent scheme as well. Not only a sequential scheme, but also a concurrent scheme. The second argument is null. Remember that this second argument is the status, okay? If we set a null, we don't store any information of how the child has finished, and if we use here a value of the pointer, then we store this information. We are not interested in storing how the children finish, so we set this second argument here to be null, okay? And finally, we have the third argument, which is the options. And we have many options. Commonly, we will use or 0 or with no hang option. If we use 0, the parent process will be blocked, okay, until the child has finished. This is what we want. But also remember, we have, for instance, another option, which is the with no hang option. This means that the calling process, okay, will return immediately if no child process has exited. So if the process of the child has not finished yet, the parent process will not be blocked. It will continue its execution. This is not what we want because we want to achieve a sequential scheme, so we need to use 0. We want the parent process to be blocked, waiting for each child, like this. Very well. Now, is this the only thing that the parent needs to do? Only to wait for each child? Well, no, right? The question statement also specifies that this parent needs to write the child's PID, the process identifier, to the screen, and also leave and exit the. So here, it is important also here to print the children, or basically the child PID. So we can print something like the son who has finished, has been, so here, or the son or the child who has finished, has been, and here we specify the PID. So we apply a substitution, okay, for decimal number. We also add a line break with \n, and here we can now access the PID of the child. How? Well, we have this inside this variable. So we copy, we paste, and here we have that the parent is going to print the child that has finished, has been, and then the PID of the child. Then the other child is going to be created, is going to be run, okay, and then the parent is going to print the same thing. The child that has finished now has been this order. Remember that this wait PID, okay, is going to wait for the signal that the child is going to send the parent when this child finishes. This is the way of how the wait PID and the exit are connected. When you use an exit on a process, okay, there's a signal that is sent to the parent process of the process that you're terminating. This is the sig child signal. We also saw this, right? When a given process terminates, the process parent is sent a sig child signal. And when this parent process receives a sig child and it is waiting for any sig child, any children to finish, then it is going to stop the blocking because we have the 0, we are blocking this parent, and we are going to print this. So with this, we also guarantee that the first that is going to be printed at each iteration of this for loop is the argument, okay? And then next we are going to print the child that has finished, has been, and then the PID of the child. Okay, very well. Finally, here we live and we close this for loop. We close this if, and then the main program. Now, very, very important here, okay, on this for loop, it is very important that on the parent code, you don't use here an exit, because if you use an exit here, then the parent process is going to create the first child. It is going to print then the child that has finished is this one, and then it is going to exit. It's not going to create a new one if we have more than one argument. This is not correct, this is wrong. So we don't need to use the exit, okay? We just leave it like this, and the parent will finish only when all of the child and all of the children have finished. Like any program, when we end this for loop and there are no more instructions to execute, the program finishes, okay? Just as any other program. Very well, so now we are going to compile this program and we are going to run and see and analyze the output, and then we can here add more things, additional things for the usage of this program. But for now, let's compile it and run. So we open the terminal of our operating system, a Unix or Linux operating system. If you don't have any Unix operating system, you can also use a virtual machine or the Windows subsystem for Linux. Now from the console, from the terminal, we go to the folder where we have saved this file, this C file we have just implemented. So in our case, we have saved this inside documents, inside the folder OS, and then we have here the folder practice. So we go to OS and then we go here to practice. Okay, and now if we list how many files we have here, we see here that we have this code, the practice C, okay? So in your case, if you have another folder or another name of the file, you just need to go to the same directory, the same path, where you have this C file. So now let's compile this program. We can compile with the GCC GNU compiler. So here just type GCC-O, the name of this executable. As we can see, we can choose program, we can choose code, okay? Any executable name, let's use the same. We can use practice. And then here finally, it is mandatory that you write the same name of your file code, okay? This is optional. The name is optional. You can use here any name. Here you need to use the same name as your file name. So now let's run. And also before running this compilation, let's verify and ensure that we don't forget any semicolon. For instance, here we need a semicolon, okay? Everything seems okay. So now let's compile. Okay, now once we have compiled this file, if we list again all of the files inside this path, now we have a new file, which is the executable file. So now let's run this file. Okay, let's use, for instance, here the arguments hi, 93, okay, and for instance also spring. Now let's run. Very well, so here as we can see, we have precisely what we expected. We have here a sequential scheme. First of all, the child prints the argument 1 is hi, this argument, okay, this is done by the child 1, and then this is done by the parent. The child that has finished has been this one with this process identifier. Then it continues the iteration, okay, because we have here 3 arguments, so this is going to be executed 3 times. We are going to create as many children as there are here, so 3. Okay, keep in mind that we actually have 4, but this is not counted to create the children. Then the child 2 here says the argument 2 is 93, okay, which is this one, and the parent process here basically specifies, okay, the child that has finished now is this one, and then this one. Okay, so this is a sequential scheme where always the child is going to print this, and then the parent is going to print this, then the second is going to print the second argument, the parent is going to be the child PID that has finished, and so on. We can here use more arguments, for instance, exam solutions on Friday. Okay, we run, as we can see now, we have 4 arguments, and this is executed 4 times, right? The argument 1 is exam solutions on Friday. Very well. So everything works right now. Finally, okay, keep in mind that we only do this if the user passes at least 1 argument, okay? But now what if the user types something like this, okay, practice, with no argument? Well, then we won't do anything, okay? And we don't want this. We want the user to know how to run this program, how to use this program. So here, we're also going to here notify the user that if the number of arguments that he provides is less than 2, essentially it only runs the program, okay, with no arguments at all. We have the else case in here, and here we are going to explain the user how to use this program with the usage function, the usage procedure. And inside this usage procedure, we are going to notify how to use this program. So we can define this procedure in here, void usage. And also that, remember that the name of this file is specified to be processes1. You can here use actually anyone, but here as the question specifies to be this one, then we can also rename this file to processes1. As we can see now, the name of this file in here is processes1. So here on the usage, you can print usage, the executable, so processes1, okay, or any executable name, argument 1, because we need at least 1 argument to create a child at this, and then we have here an extra set of arguments that we can have. So from the argument 2 until the argument n that we specify. So normally in programming, when you want to represent optional things, use here this square brackets, and we want to specify mandatory things, we use here just the argument name normally. And here we can also, for instance, provide information to the user, such as the program creates as many processes as it receives arguments -1 sequentially. Okay, so here it is very important, because if the user does not provide any argument, only runs the program, then we will here print this usage, okay, information. So let's save this, and also let's recompile. So now keep in mind that since we have renamed this file, we list again, we have this processes1.c. So now we compile, just c-all. Let's name this to be, for instance, processes1 also. And here we have processes1.c. We compile, and now we run this program, processes1. Okay, normally we can here give 2 arguments, for instance, computer, okay, machine. We run. The program works correctly, okay, the argument 1 is computer, the argument 2 is machine, but what if we just here run this program without any argument at all, right? So here, the argument counter, C, is less than 2. We only have the executable. So now let's run this. Okay, so perfect, we see this message of the usage, okay, the usage is this one, we need to provide at least 1 argument, this program creates as many processes as it receives arguments -1 sequentially. So if the user didn't know how to run this program, now it has the information and can now introduce arguments in here, for instance, weather is good, right? And we will have here the execution of this program. Again, very important to remember, okay, this is a sequential program. This notion of sequential scheme is very, very important. With this, we end the solution to the first question of this practice. We remind the student that you can download all of this code and all of this solution file on the downloadable documents of this lesson.